So today we'll discuss about deep learning concept and its formulation. Actually, we know the term deep learning here and there, and nowadays it is an emerging topic for industry as well as research. But what is the deep learning? Why do we so much interested on this topic? After going through this session, we will able to learn it, and then we can understand the how can we model a deep learning systems. Okay, so this is the case, and all of us are well known about the term artificial intelligence, and we know what is it. The artificial intelligence is any machine which can perform like human being is called artificial intelligence machine. So we want to train our machine such a way so that machine be an intelligent machine, and machine learning is a way to make the machine intelligence. There are lots of applications. Actually nowadays various industry are doing this kind of research. First one is sentiment analysis, second one is sarcasm detection, machine translation, maybe fake news detection, recommender system and all. I will going through a quick demo, then I will start it, then it will be more visible to us. I'm going to give you a little demo. Okay, so this is the sentiment analyzer. This is sentiment analyzer, and here if I give any sentence then or any paragraph, it will make us, actually it will tell the sentiment in this sentence. For an example, suppose I want to purchase a mobile and I want to know the rating in it, because when we want to purchase anything, we are very much interested to go for the user reviews, but there may have 1,000 or 1 lakh user reviews, but it is difficult to read all of this, so automated system is required. So this types of system is good for that. Suppose the iPhone, suppose this is normal, it will be better. Suppose the quality of the camera is good, then it must be positive sentiment. So it is positive sentiment having 98.4% confidence score. Suppose this is written is the quality of the camera is bad, then it must be negative. So this is negative with having 98.6 confidence score. Suppose I'm writing I am Dr. Debajyoty Banik. So there is no sentiment, it is neutral, so it must be neutral. So this is neutral having 83.6 confidence score. So from this, so we can understand that whether the user give the positive feedback or negative feedback or normal feedback, neutral one. So this is one of the applications. Another types of application could be this, that is sarcasm detection. This is another types of examples. Actually nowadays various platform, we are in the various platform, we are doing the sentence which is in a sarcastic way, that is kind of diplomatic way. Actually nowadays we don't want to hurt anyone, so we can say any negative sentence in a positive manner, so that is sarcasm. And various companies like Facebook and WhatsApp and other also actually working on the sarcasm detection techniques. And in social media they wants to identify whether the sentence is sarcastic or not. So there is a sentence, this is not an office, it's a hell with fluorescent lighting. So let's generate it. This is sarcastic sentence having 64.92 confidence score. Suppose I am writing another one, suppose a non-sarcastic way. Suppose he is a very good researcher. He is a very good researcher. There is no sarcasm inside it, so it must be non-sarcastic. So it is an automatic tool, and in industry, its demand is increasing. Next one is Google Translator. This is a machine translation system by which we can translate one language to another language. You know, this is very much important, because when we will go to a unknown place, and if the language is totally unknown to us, then we can use this system to convert one language to another language. Suppose we want to convert English to Hindi. For the example I am writing, I am Dr. Debajyoty Banik. I am the faculty of KIIT. So may Dr. Debajyoty Banik ho, may KIIT ka faculty ho. So like this, you can translate any language to any other language. I think this tool is very much familiar to you also. Okay, so like this way, companies are working on it, so we can understand that demands of this kind of systems are increasing day by day. So this is the main reason why we are very much interested on this kind of techniques called machine learning or deep learning, because machine learning and deep learning, using machine learning and deep learning, we can build this kind of systems. So this is the main thing behind this subject or behind this topic. Why do we interested on this topic, deep learning or machine learning? So this is the case. So if we want to build such kind of systems, we can use any techniques. That is that could be the supervised learning, unsupervised learning, semi-supervised learning, or reinforcement learning. Actually, these are various types of machine learning algorithms. Actually, when we have large amount of data, labeled data, then we may use supervised learning. Labeled data means, what is labeled data? Means suppose I need to have I want to decide anything. Suppose there is a sentence, and this sentence is positive sentence, negative sentence, or neutral sentence. Then every sentence along with its sentiment value, not value, sentiment class, will be labeled. Means suppose there is a sentence, he is good boy, this is positive sentence, so positive will be labeled. He is not a good boy, so this is negative, so negative will be labeled. So like this, if we have a data set, then supervised learning may come into the picture. If there is data set, means only first sentence or paragraph or anything, but we don't have the label data set, then we can use unsupervised learning. If we have mixture of these types of data set, then we may use semi-supervised learning. And in the same semi-supervised learning, maximum chances we have many unlabeled data and few labeled data. And nowadays reinforcement learning is improving, and it is very much efficient methodology. And using this in reinforcement learning, actually what is it? Actually it can allow machine or software agent to automatically determine the ideal behavior within the specific context. And when the agent will identify that stuffs based on the inputs, then he can take the decision, and after taking the decision it will be performed, that is called action. And when it will act, then it will be rewarded. It will be rewarded, and this rewarded things will be stored into the environment. So this is the case. This is little bit inside of the supervised learning. Actually, supervised learning is based on the predictive model. we have label data. This is already discussed. And supervised learning may have regression or classification problem. What is regression and what is classification? Because these two terms are new here. Classification means there must have a category. From the previous example, we told that this is positive sentiment, this is negative sentiment, this is neutral sentiments. So these are class, these are category. Or in the other way, we can say that whether suppose a movie is going to release, and we want to predict whether the movie will be hit or flop in box office. So hit and flop are two class or two categories. So supervised learning can come into this picture to solve this problem. So this is classification problem. If we want to know how much money the movie can generate from this box office, this is regression problem, because some value is generating. In the first case, in the classification, we are classify, and in the second case, we are generating some value. So when this kind of scenario will come, this is called regression problem. And there are so many algorithms in the supervised learning. I enclose some common algorithms. Those are nearest neighbor, naive-based, decision tree, linear regression, support vector machine, and most importantly, neural network, which is part of deep learning. In the unsupervised learning, this is another category. You know this. Actually, we have already discussed it. Actually, the machine is trained on unlabeled data, and this is descriptive model. And the main types of unsupervised learning are also clustering algorithm or association rules learning algorithms. And the most common algorithm are k-means clustering and association rules. So these are the unsupervised. And for the semi-supervised, actually it has the combination of supervised and unsupervised machine learning methods. So it has the advantage over both of the machine learning approaches. It provides the benefit from in each and every types of systems. So this is the case, and these consist of label and unlabeled data. This is already discussed. So that's why combination of supervised and unsupervised machine learning methods can come into this picture. This is reinforcement learning. This is already discussed. Actually, here the state observed state by agent only, and decision making by its action, and after the action it could be avoided, and the state action will be stored in the machine. And these are common algorithms for reinforcement learning: Q learning, temporal difference, deep adversarial networks. This is quick overview of all types of machine learning algorithms. This is the quick overview of all. That is, machine learning algorithm can be supervised learning, unsupervised learning, semi-supervised learning, or reinforcement learning. And in the supervised learning, we must have a data. So it could be continuous target variables or categorical target variables. Means if for this, okay, for categorical target variables, for this means we have the categorical data as label. That is, it could be positive sentiment, could be negative, could be neutral. So there are three categorical classes. So these are the target variables. If these are target variables, so it will be classification task, because this is based for the classification. And there are lots of application for it. One example is here, that is medical imaging. Another can be continuous target variables, which is for the continuous data, means any value. So regression problem will come into there, because I told that for the regression we need not to have the classification, we need to have the specific values. And housing price prediction is the one of the application, because this is price is a value. So like this, there are other types of, this is unsupervised. For unsupervised, we need not to have any data, label data. So that's why there is no target variables, and it could be clustering or association. For clustering, customer segmentation will be there. For association rules, we may have market basket analysis. This is a project. Another thing is semi-supervised. When the categorical target variable is there, for classification, text classification can be done using these systems, and land finding on GPS data. For this application, we can use the clustering technique. For reinforcement, there may have two types of variables. One is categorical, another is no target variables. If there is a categorical variable, then classification will come into the picture, and this is one of the examples, that is optimized marketing. If there is no target variables, then control will come into the picture, and driverless car is the most important application of this. Right now, various companies are working on this, on the driverless car, like Google also, and other company also. Tesla is one of the example of this. Okay, and this is also in a research phase, so there is a huge scope. So till now we are discussing about the various types, and we told that AI is a umbrella, and inside it we can implement this using ML. ML means this could be supervised, unsupervised, semi-supervised, or anything, or neural network. If neural network is will come into the picture, and there are several hidden layers, then it will come into the deep learning. Deep means more than one hidden layers. So it will be come into the picture, the deep learning. So this is kind of, this is nothing but the neural network, deep learning. So deep learning can be classified supervised deep learning and unsupervised deep learning. For the supervised deep learning, you already aware of the stuff that for the supervised machine learning we need label data. So as well as for supervised deep learning, we need to have the label data, and label, if we if we label as y, and if we pointed out features as x, then y will be function of x. So this is y is equal to function of x, where y is the label or target and x is the features. So this is the case, means sentiment will be function of features. Features means the text inputs, there may have a various property inside the input, that input will be called as features. And for this we may use various types of algorithm like ANN, CNN, RNN. ANN, for CNN, actually ANN can be used for normal use, normal application. CNN can be used for the, CNN means convolutional neural network, it can be used for the computer vision. It may use for other application also, but for the computer vision it perform good. And right now we may use transfer learning also. If we have existing model and we want to take the advantage over this, then we can use the transfer learning. Normally for the computer vision we use this kind of techniques. And the most advanced technique is RNN, recurrent neural network. There is a memory component which is the advancement over the previous approaches. There are memory component in the RNN, so this can use more efficiently. A Gmail suggestion, stock market analysis, time series analysis will come in this picture. So RNN can be used to solve this kind of problem. Actually Gmail suggestion means what? When you will reply to anybody, then after writing something, Gmail will suggest you that what the next word should come. That is called Gmail suggestion. Actually in the background, the Gmail background of the Gmail suggestion, he used the RNN techniques. And another techniques are another technique is the unsupervised deep learning. Self-organizing map is one of the its types, one of the algorithms. Another algorithm is Boltzmann machine, but this is not in use nowadays. nowadays there is an advancement of Boltzmann machine that is called autoencoder, and recommendation system use this kind of algorithms. But after using this also, we may not get exact accurate systems. This could be the problem of our model, or this could be another thing. What is the another thing? That is external stuffs may affect our model accuracy. That is the case. So what is the external effect? That is for this time being, we have predicting we have the we have a model which can predict the sales to the upcoming year. And nowadays corona has come, so corona can affect this system. Due to corona, we may not get so much profit which we predict. So that's why we can say that external stuffs may affect this. Now you can wait. You may ask, sir, there are so many techniques, machine learning, deep learning and all. So where should we use which systems? Can we use any system anywhere? If you want to do this, then if you are very new in this topic, then you may use any system anywhere. But for the industry point of view, for the research point of view, you should not use any system anywhere. This is based on your resources. You can use different different types of techniques. That is, if your resource is high, means if your data size is high, if you have large amount of data set, then you must use deep learning. How? Why? This is a curve. This is the data size and this is the performance, and this is the machine learning performance. Means at this point, up to this point, if you increase the data size, then machine learning performance will be improved. After this, it will be stuck. But for the deep learning, at the initial stage, it will not give you better accuracy if you have less data, but after certain time, it will be increasing for deep learning. So from this diagram, it is clear that if we have large amount of data set, we will use deep learning, otherwise we will use machine learning. This is one of the things. Another thing is resources. If you have good computation power like GPU, TPU, then you may go for the deep learning, because deep learning is require more resources. For the normal machine, you may use machine learning systems. Normal traditional, maybe statistical based analysis, maybe rule based analysis can come into the picture. So this is the machine learning versus deep learning approach when you will which system. So artificial neural network, which is supervised neural network, may have regression or classification, that is already discussed. So I am not repeating it again. Only I can say there are so many applications. Some applications are there for the regressions, that is predicting markets or predicting marks or predicting salary or how much money will made in the box office for a movie, or what is the grade, predicting grade. Grade means not A, B, C, D. Grade means marks. I'm talking about the marks. Okay, 98%, 92%, like this. If you are going for the grade A, B, C, D, then it will come under classification techniques, or qualified or not, or movie would be hit or flop, or guy will get the job or not. So this will come into this system. This is actually the overview of our brain and artificial neural network. And here this is a pictures or any data, and this is actually human brain. Okay, I'm talking about human brain. We perceive these pictures using our eyes, and then it will come into our brain, and there are 5 layers inside it. And after this, we can decide about this picture. Even I am very much sure that you have some idea about this picture, and inside it you can recall various things from the movie or from this scenario or from this scene, or even if you don't know about it, you can judge something from this picture. So this decision you can take after passing these things through 5 layers which were present inside our brain. So this is the case. And ANN, if we use the machine, the similar steps will be followed. So this is the again another image. So image will come, and after some layers it will predict the output. This is prediction. And the first layer is called input layer, and the final layer is called output layer. And in between all of the layer is called hidden layer. So if we have n layers, then how many hidden layer will be there? N minus 1 and 1, 2. So n minus 2 hidden layer will be there. Okay, so this data can be processed using such layers. So after that, if we took any of the layer, how will it be modeled? So how it will be look like if we take one of the layers? So let's see. So this is one of the layer. So inside the layer there are so many nodes or perceptron. These nodes are called perceptron. And if we took any of the nodes, then the node will look like this. What is it? This is one input will be coming inside it, and output will be generated based on some factors. Those are weights, biased, and it will pass to the activation function, and activation function will generate the outputs. This is the inside the nodes. Then you can ask me, sir, we know this until till now it is clear, but mathematical formulation may be tough. For you, I can let you inform that mathematical formulation is not tough for this also. Even you know the mathematical formulation behind it. You already know. Recall your +2 standard. For even 10th standard, you studied the straight line. For straight line, what was the equation? Y is equal to ms plus 6. Y is equal to mx plus c. It was the straight line equation. And here also we use this one only. Don't be misguided with other terms. Okay, from this straight line we can transfer this. How? Here for the straight line m, it is a slope for straight line, but here it is a weight. This weight will be replaced, this straight line slope will be replaced by weight, and this c, that was intercept in the straight line, here it is biased. So finally our equation would be like this: output is equal to input into weight plus biased, and it will be passed through activation function, this one. So this will generate the outputs. So right now we know all of the stuffs. Now I am going to the little bit inside it. Means we know input layer, we know output layer, we know hidden layers. But how many nodes will be there in the input layers? That is one of the questions. So the number of inputs, number of nodes in input layer would be number of features. Suppose for this salary prediction problem, what could be your features? Qualification, your department, your experience, your award. Suppose these 4 are selected for the as a features. So your node counts in input layer will be 4. But you can ask me, sir, for this prediction or for this text it is easy, But for the image, how can we calculate the nodes? That is based on your pixel. So, and for the image, every pixel can be considered as a features. So for an example, if we have 25 cross 25 image, then what is the total pixel count? So that is 25 into 25, that is 625. So we need to have 625 nodes as input layer. So this is the nodes count in input layer. When you will implement it, you will look into it. Okay, based on this you can easily fix the nodes in input layer. What about the nodes in output layer? In nodes in output layer, in based on the problem, based on the problem, if this is a regression problem means what? Regression problem means we need to predict some value. Value means what could be the salary, how much profit can be there, so like this. So if this is regression problem, then only one node is sufficient for this problem at output layer, only one node. If this is classification problem means there may have class categories, positive, negative, neutral, positive, negative, neutral, or we may classify a image as cat, dog, or cow. So for this example, cat, dog, or cow, or any other example you can consider. Actually, classification, for the classification, the number of categories will be number of nodes. Number of categories will be number of nodes. Why and how will it be working on? Like this. Suppose we have 3 class, cat, dog, and cow. Then we will consider each and every nodes for a specific which can be associated for a specific category. Suppose this is cat, first one is for cat, second one is for dog, third one is for cow. So when first node is enabled, that is 1, then that means it is cat. If second node is enabled, then we can say this means this is dog. If third node is enabled, then we can say this is cow. Similarly, if this is binary classification problem, then only single node is enough. Why? Suppose a person will promoted or not, then if the node is 1, then we can say he will promoted. If the node is 0, then we can say he will not be promoted. So only single node is enough at output layer if this is binary classification problem. Number of nodes in hidden layer, this is another technique. Actually, as per literature, there is no fixed numbers, but we can predict it based on the empirical analysis. This is some guiding numbers which you may use to make it accurate. That is number of nodes in hidden layer, approximately 2/3 of nodes in input layer plus nodes in output layer, and it must not exceed 2 times of node in input layer. So this is a guiding number for the nodes in hidden layer. So node in output layer is done, node in hidden layer is done, node in input layer is done. So now you can ask, then how many hidden layer can be there? How many hidden layer? So actually empirical analysis will say how many hidden layer will be there for this specific problem, for the specific data set. But we can say that if you increase the hidden layer, your model will be so complex. Complex means you require more RAM or more computational power if you increase the hidden layer. And complex model leads to the overfitting. What is overfitting? Overfitting means at the training time you may get good accuracy, but for unknown data at the test time you may get proper output. Okay, so this is the so we will not make our model more complex, but if we minimize it, then you may suffer for the underfitting, means you may not get good accuracy. So that's why middle way is better, and that is the reason we will fix this one using hit and trial methods. So after this, I can say one thing, that is all of this is done. Actually some picture is actually this arrow is here and there, actually don't confuse with this. Okay, actually this is I'm explaining it. Actually each and every nodes is connected to each and every nodes in the next layer. Okay, so don't confuse with these arrows. Actually it is some formatting problem, I think. Okay, don't worry. So actually what do we want to convey it from here, that is input layer for a specific layer's output will come to the next layer, and the next layer will come to the next layer. And if we took any of the nodes, then this node will be look like this. You know this inputs, lots of inputs will be there for these nodes. The input will come from these, from these, from this, and from this. And when it will generate the output, that means it will be based on some activation function, which is function of all of the inputs, bias and weights. And this is look like this activation function of I1 W1 plus I2 W2 plus I3 W3 plus I4 W4 plus bias. So this would be the output, and this output will go to the next layer's nodes. So this will go to here as well as here, and so on. So this is the concept of dense layer. Right now you can ask, sir, you told us that there are so many activation function. So which activation function should we use which times? Again, that's based on the problem, but in the input layer we need not to have any activation function to, but in the hidden layer we use ReLU. We may use tan H also, no issue. Even earlier times we used the sigmoid, but to overcome the gradient vanishing problem we used ReLU. ReLU is working very good for this for the hidden layers. And for the output layers, this is again based on the problem. If this is the regression problem, there need not to have any activation function. If this is classification problem, and if this is binary classification, then we will use sigmoid and for one node. And if this is multi-class problem, then we will use softmax function. Why? Then again question may come, why? So let's go for the inside of the activation function. This is the ReLU. The function of the ReLU is, if x greater than 0, output will be x. If x less than 0, the output will be 0. That means all of the negative value will be omitted from here. So this is the case. So negative value is not there, and the value which is positive, it is not small. So vanishing gradient will not be there. So it will be effective for the hidden layer. For the sigmoid, if we generate, if just generated for suppose any nodes, suppose this is in the final output layer node, it generates a probability value, and if the probability value is greater than is equal to 0.5, then we can say this is class 1, or if this is less than 0.5, we can say this is class 0. So for the binary classification, sigmoid is enough. You can understand why. For the softmax, I told that if this is a multi-class problem, we will use softmax. Why? Suppose for the previous example, cat, dog, or cow. Suppose for cat, the probability generated probability is 0.2. For dog, the generated probability is 0.7. For cow, the generated probability is 0.1. So among these three, which one is the greatest value? That is 0.7. With whom it is associated? That is with dog. So dog will be 1, and rest of the other category will be 0. So that's why softmax is beneficial for the multi-class problem. This is actually when we will go for all of this to make it accurate, to make the model working, we need to have the back propagation. Maximum of us are very much familiar with this back propagation. What the concept behind it? What the concept? So let's have a example, or let's play a game that will be better. Suppose there is a target. Suppose this is a marble. Okay, this is a marble. There are 5 cards. There are 5 cards. If I push the L1 card, it will fall into L2, and L2 will be fall into L3, and so on. After coming to L5, L5 will be fall into here. And if it touches the marble will be falling down. Otherwise, no effect will be done. And our aim is to make this marble falling down. So suppose let's try first time. Suppose it's L5 come and it stuck at here. Okay, it could not touches this marble. So what should be our next step? Our next step is we will change the position of the L5 here to here. Okay, we'll change it little bit randomly. Change it, and accordingly all of the other cards position will be changed from here to here, then here, then here, then here, and finally after certain time we can able to touch this marble. So this is the concept of back propagation. Means to make our target fulfill, we will change the position little bit, delta amount of changing. So this is called back propagation. In the real life, means in the technical point of view, these cards positions are called weight, which are randomly initialized, which is near to 0 but not 0. But we will change this delta position until and unless we need not to meet our target. So all of these L1, L2, L3, L4, L5 are layers, and L1 is input layer, L2, L5 is output layers, and L2 to L4 are the hidden layers, and positions are the already told. This is random and this is weights, and change of the position, this is delta X, this is called learning rate. Okay, so this is the case, this is the concept of back propagation. So if I took it more into it for the technical analysis, then we can say after passing through our layers, our data can predict, our model can predict something, and the prediction and actual result may have some difference, and this difference is called error. Suppose our predicted value is not equal to our actual value, so the difference is called loss or error, and cost function measure this loss. Cost function measure this loss, and based on the cost function we can back propagate to our models and change, and we can change the weights. Okay, so and changing the weights, we will change the weight so that cost function is minimal. And who will say this, that our cost function will be minimum if I change the weight such a way? Gradient descent. Gradient descent will say that if we change the weight such a way, then our cost function will be minimum. There are some points, some functions are noted here. These are available in Keras for loss function. Okay, you can look into it. If you use Keras, then you may use any of this loss function. This is the gradient descent. Actually, I want to give you more insight into the gradient descent because this is very new term for you. Actually, from this curve, this is weight, and this x-axis is depends on weights, and y-axis is based on the loss or cost. So for which weight our cost is minimum? For this point, if we choose this weight, then our cost will be minimum. So we should identify this one, and gradient descent will identify this. How? Suppose randomly, at first we told that randomly initialized weight and the first time, and the second time when we will change it, if the slope is negative from here to here, so slope is negative, sloping is down, so slope is negative, so that means we will improve the weight, we will increase the weight. if slope is negative, suppose we are here, so slope is positive, so we'll go down, means we'll decrease the weight. Okay, so this is the case. And how many times should we continue the process? For the gradient descent, it maximum 1000 time it can continue the iteration. After the 1000 time it will stop the iteration. And you can look into this equation. Okay, this is nothing but this only. Actually, new weight will be old weight minus alpha, it is learning rate, and derivation of the error respect to weight. That is only this one, means the delta change. It's talking about the delta change. And there are various optimizer in the Keras. I have mentioned some of the optimizer which can be found from Keras. Okay, so you can use any of this. In the keras.io you can get the documentation as well as the implementation part also. So these are the available optimizer in the Keras. This is the conclusion, means how can a model work. This is overall overview. When we will get a inputs, it will pass to a layer, and layer will be randomly initialized with the weight, and then we will go, our data will be passed, means our information will be passed to the next layer and so on, and finally it will predict something. And then using loss function we will calculate the difference between true target and prediction, and then we will calculate some loss score, and based on the loss score the optimizer works, and optimizer will let us know that what would be the possible weights, and the weights will be again initialized, and this process will be continuous until the satisfactory result comes. And then if it is okay, if we satisfy with the result, then the model is prepared, then unknown data can come to make it prediction. So unknown data can be passed through the model to predict the output. That's all. Thank you all. Please let me know if you